In this video, we will look at the concept of variable scope in the context of control flow constructs. Previously, we looked at sequence structures. They are the simplest of the three control structures. Lines of code in a code block get executed in sequence, one by one. When a line of code is being executed, a variable can be thought of as either being visible or not. If it is visible, it is in memory and your line of code can access it. If it is not visible, then it is not in memory, and your line of code cannot access it. So far, we have used a simple rule for variable visibility. We have said that the variable is visible in the lines of code after the line in which it was declared. If you use a variable before it is declared, then you get an error. So far, this simple rule has been okay. But now that we are using explicit control flow constructs, we will need to modify it. We need to understand variable scope in more detail. Variable scope refers to the visibility of the variable. The scope of a variable is the lines of code where that variable is visible. For any line of code, we can say that a particular variable is either in scope or out of scope. Or sometimes we say that it is in context or out of context. An important aspect that we must now consider is what happens at the end of a code block. Different languages take different approaches. We will focus on the approach called block-scoped variables. It is the approach taken by Mobius. In particular, we will focus on what happens to variables when execution reaches the end of the code block. When there is only one code block, this may seem irrelevant. But when there are many code blocks, it will become very relevant. The variables that we declared in a code block will all go out of scope when execution reaches the end of the block. That means that they will disappear from memory and no longer be accessible. You can visualize it as the variables all being thrown into a fire and destroyed. Maybe this seems like a bad thing. Actually, it is a good thing, since it avoids many errors and bugs. It means that all the temporary variables that you declare in your block will all automatically get cleaned up. Let's look at this in more detail. Code blocks get created wherever control flow constructs are used. So each time a conditional construct or looping construct is used, it results in a new code block. The code blocks are nested inside each other. In the diagram we can see the main code block with a conditional construct inside it. The conditional construct results in two code blocks, the true code block and the false code block. Here is a similar structure in code. We can see the code blocks by the level of indentation of each line of code. We can see that there are still three code blocks. There is the main code block. Inside the main code block, there are two nested code blocks. The two nested code blocks result from the if-else statement. We can also add more control flow constructs, with deeper nesting. For example, here is A for each statement nested inside the if-else statement. We can see that the nesting is now 3 levels deep. Now let's have a look at what happens to our variables at the end of each of these code blocks. We have 4 code blocks. So there will be at least 4 times that execution reaches the end of a code block. In fact, it is more, since one of those code blocks is inside a loop. The end of the code blocks are highlighted here by the orange lines. So we have already seen what happens at the end of a code block. Each time execution reaches one of these points, variables may go out of scope. That means that those variables will be destroyed. So the lines of code that follow will not be able to use those variables anymore. Let's look at each of these in turn. The first code block to end is the if code block. two variables were declared in this code block, called C and these variables will therefore go out of scope. The next code block to end is the for each code block. Since this is a loop, this code block is executed 5 times. Each time, two variables are declared, called I and F. And each time, these variables will go out of scope. The next code block to end is the else code block. Only one variable was declared, called E. This one variable will go out of scope. Finally, the main code block ends, and everything that remains goes out of scope. In this case, what remains are 3 variables, called A, B, and X. With so many variables getting automatically destroyed, you may be wondering if there is a way to prevent it. Let's look at 2 examples. Here is an example of a simple if construct. Inside the if code block, you declared a variable called D. Let's say that you want to use that variable further down in your code. At the moment, the variable will go out of scope when the if code block comes to an end. So you will get an error. What can you do to keep that variable in scope? The scoping of a variable is linked to the code block in which the variable is declared. If you want to keep variable in scope during the whole of the main code block, then you need to declare it in that code block. In this case, in line 3, we declare variable and set its value to 0. The code inside the if block does not change. But now it is only changing the value of t. It is not declaring a new variable. As such, variable will not go out of scope. We will look at one last example. In this example, you create a list data structure. And you create a loop and put some values in the list. Let's say that at the end of the main block of code, you want to do something with your list. Here, as an example, we just get the length of the list. The list is not declared in the for each code block. So at the end of this code block, it remains in scope. But list is declared in the if code block. So at the end of this code block, it goes out of scope. In order to fix this, you need to move the list declaration 1 level up. You need to declare the empty list in the main code block. That way it will remain in scope until the end of the main code block.